Recently, the 26th Conference of Parties decided to discuss reducing carbon emissions to minimize the dangerous effects of climate change for us humans. However, CO2 reduction does not only work to save us, but is also a means to save underwater species as well. There are layers and layers of reasons why the increase in atmospheric carbon dioxide is a threat to the human existence and animals as well. So first of all, let's talk about how are they formed. There are two reasons how atmospheric carbon dioxides are formed. First is due to natural sources. These are carbon dioxides that are excluded from animal bodies as a waste product. And secondly is the human activities, mainly based on energy production, which is, for example, coal burning and later on being turned to hydrocarbon gases such as methane and propane. Now that we know how CO2s are formed, let's talk about how are they increasing throughout the decades. So statistics show in the 1960s that the amount of carbon dioxide, the global average, is 320 parts per million. Fast forward to the year 2000s, the amount increased to 50, making the overall global average 370 parts per million. Now let's go to the year 2020. The amount reached 412 parts per million. So this is a 12% increase since the year 2000s. So what we can conclude from this is that the amount of carbon dioxide filling up the earth is exponentially growing. And the abnormal growth comes from human activities, mainly involving the use of fossil fuels as a means to extract energy. Earlier, I mentioned that decreasing carbon emission will be beneficial to the marine welfare. Well, increasing the amount will do the opposite.
The atmospheric carbon dioxide is dissolved in the seawater. Afterwards, carbon dioxide reacts with water to form carbonic acid. Carbonic acid then splits up into its ions, namely bicarbonate ion and hydrogen ion. Bicarbonate ion can further dissociate into hydrogen and carbonate. The hydrogen ions produced increase acidity, lowering seawater pH. Calcifying organisms such as corals, clams, and crustaceans use the carbonate ions to make shells. Then what does acidic seawater tell us? Because carbonate ions react more easily with hydrogen than with calcium, higher concentration of hydrogen leads to lack of carbonate ions for these organisms. It is also important to note that bicarbonate ions cannot combine with calcium.
So this process is called ocean acidification. Ocean acidification will cause shells of underwater species to corrode and also destroying coral reefs, a home for many sea creatures. And the ability of some fish to detect predators is decreased in more acidic waters. When these organisms are at risk, the entire food web may also be at risk, and we humans currently are the invasive species that's causing all of this in the ocean.
So far, ocean pH has dropped from 8.2 to 8.1 since the Industrial Revolution, and is expected to fall another 0.3 to 0.4 pH units by the end of the century. A drop in pH of 0.1 may not seem like a lot, but a pH scale, like the Richter scale, for measuring earthquakes is logarithmic. If we continue to add carbon dioxide at current rate, seawater pH may drop another 120% by the end of the century to 7.8 or 7.7, creating an ocean more acidic than anything for the past 20 million years or more. If the ocean and coastal acidification disrupts organisms and food webs, we can expect the ripple effects to result in major changes in the ecosystem. The rapid pace of acidification will influence the extent of which calcifying organisms will be able to adapt. The impacts of the ocean acidification are not uniform across all species. Some algae and seagrass may benefit from higher CO2 concentrations in the ocean, as they may increase their photosynthetic and growth rates. However, a more acidic environment will harm other marine species such as mollusks, corals, and some varieties of plankton. The shells and skeletons of these animals may become less dense or strong. In the case of coral reefs, this may make them more vulnerable to storm damage and slow the recovery rate. The effect of increased ocean acidity on one type of organism can have serious consequences for an entire ecosystem, including people. Approximately half a billion people globally depend on the coral reef ecosystem for food, coastal protection, and income from tourism and fisheries.